So in this video, I'd like to discuss transformation. So transformation is a powerful idea that underpins all of math and physics. Okay, it's the idea of taking an object and changing it in some way, transforming it. Okay, it comes in lots of different names in mathematics. So you can talk of a transformation, but you can also talk of a mapping, or an operation, or a function. Okay, all of these terms they mean broadly the same thing. Okay, so what I'd like to do is demonstrate the different types of transformation. Okay, we're going to use as our object an equilateral triangle in the two-dimensional plane. So the first type of transformation that you can do is a translation transformation. So you take your object, in this case an equilateral triangle, and you move it a set distance in the plane. Okay, you translate the triangle a certain length. Okay, and all the points on the triangle get moved the exact same length. You can move either in the x direction, or in the y direction, or in some combination. Okay. The next transformation we're going to talk about is a rotation transformation. So if you start out with this equilateral triangle here and rotate, you get another equilateral triangle. Okay, that's a rotation. It's rotating about the origin. So the origin is the center of rotation, and it's rotating, in this case, in a clockwise fashion. Okay. The next transformation is a reflection transformation. So in this case, you have an equilateral triangle, and we're reflecting it in the x-axis. So the x-axis is our line of reflection, or axis of reflection. And what you do is you start with the point on the object, and you move down to the x-axis, and then you move down the same distance again. And this works for all points on the object. You move down from the point to the line of symmetry, the axis of reflection, and you go the same distance again. Okay, this is a reflection operation in the x-axis. You could do the same thing. You could do a reflection in the y-axis, or you could do a reflection through the origin. Okay, and the last transformation we're going to talk about is a scaling transformation. Okay, this is where you increase or decrease the size of the object. Okay, so scaling involves stretching or compressing. Okay, in this case, the equilateral triangle is blown up into a larger version of itself. Okay. The other interesting thing to reflect on when looking at these transformations is invariance. So invariance under transformation is an extremely powerful idea, and that's actually what underpins most of our theories in physics. So in this instance, you can see there are a couple of properties of this equilateral triangle that are invariant under transformation. So if you look at each of these transformations, they all preserve something of the original triangle. So one thing you can think of is, if you look at translation, we'll give this the symbol T, translation. Rotation will give the symbol R. Reflection will give the symbol RF. And scaling will give the symbol S. Okay, the translation transformation, the rotation transformation, and the reflection transformation. These transformations preserve the length of the sides of the triangle. Okay, under each of these transformations, not one of the side lengths is altered. Okay. Another invariant property under these transformations is the angles. So the angle inside these equilateral triangles, they're not affected by these three transformations here. And the last one is area. But of course, area is invariant because the length is invariant. So these are the two more fundamental properties. But the area of these triangles are invariant under translation, rotation, and reflection. Okay. If you look at the scaling transformation, okay, scaling transformation does not preserve length, and therefore also does not preserve area, but it does preserve angle. The angles inside these triangles are the same. Okay, so it's often very fruitful to think about invariance under whatever transformation you're dealing with.